So we're going to calculate a couple definite integrals here, and we'll talk a little bit about the notation. So the first thing we do is we find the antiderivative of our integrand. So we had some practice at that, so we're going to use our rules. So the antiderivative of x cubed is x to the fourth over 4 plus the antiderivative of 2x. Remember, increase the exponent by 1. That becomes a 2 divided by 2. The antiderivative of 2x is x squared, because the derivative of x squared is 2x. Minus 1, the antiderivative of that is minus x. Now we do not need a plus c here, because this is going to be a definite integral. It's not a family of functions, it's actually a value. So what we do is we put a bar behind our definite integral, and then put in our limits. So negative 1 to 5. What this bar in the back tells us is that we've taken the antiderivative, but we have not yet incorporated our limits. That's why we put it behind, and it's just a line or sometimes a bracket. Now we need to put in our limits and apply our fundamental theorem of calculus. So is the top minus the bottom, or upper minus lower. So we have 5 to the fourth minus 4 plus 5 squared minus 5. So that's putting in our upper limit into our antiderivative. Minus, it's always minus. Now we're going to put in our lower limit. It's a good idea to put that in parentheses. So negative 1 to the fourth over 4 plus negative 1 squared minus a negative 1. Now we get to go ahead and calculate. So 5 to the fourth is 625 over 4 plus 25 minus 5. Now I'm going to do two steps at once. I'm going to distribute this negative sign and also simplify everything that's inside. Negative 1 to the fourth is just 1, so it's a positive 1/4, but then when we apply the negative sign, it becomes a negative 1/4. Negative 1 squared would be a positive 1, but applying this negative, it's going to go back to negative. And then again, would have had a positive 1 here. We would have had a positive 1 here. Applying that negative, we have another negative 1. Now we'll go ahead and combine like terms. So we have 625 fourths and a negative 1/4. 624 fourths. 25 minus 5 is 20. Minus 1 brings us down to 18. Now we need to combine those. And let's go ahead and do it as a decimal. 624 over 4 is 156 plus 18, which gives us a total of 174. Now, of course, after we find this, we would go ahead and check this with our calculator, make sure we got the right answer. But that's how we can calculate a definite integral by hand. We'll do one more quick example. So we have the integral from 1 to 5 of 2 over x dx. So first thing, we don't need the constant in there, so I can pull that out of the integral. So I can rewrite it as 2 times the integral from 1 to 5 of 1 over x dx. I'll just leave this constant up front and apply it later. I need the antiderivative of 1 over x. The antiderivative of 1 over x is the natural log of the absolute value of x. Again, we don't need the plus c when we're doing a definite integral. We're going to be taking the difference anyway, so any constant would just cancel out. So we can just remind ourselves that we still need to put in our limits. So we have 2 times the natural log of the absolute value of 5. Well, 5 is a positive number, so we can just write it as natural log of 5 minus, we should put that in parentheses, the natural log of 1. Any simplifying we should do. The natural log of 1 is 0. So we get 2 times the natural log of 5 for our final answer. Notice that both definite intervals came out to be numbers, and we don't need the plus c when we find the antiderivative in this case, only for indefinite intervals.